All right, welcome to Chapter 12, Section 2, called Angles of Triangles. This is for Integrated Math 1, or IM 1. All right, so just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. All right, so the triangle angle sum theorem. Like I was just saying, all triangles, no matter what triangles I draw, so I can draw any triangles I want here, and I can draw a nice big wide one. Doesn't matter how I draw a triangle, the angles of a triangle have to add up to 180 degrees. So that's what the triangle angle sum theorem says. Okay, so this is a little animation. I was going to try to do it on my other screen, but it's not working nicely. So we have a triangle here, and they're showing us the three angles of a triangle, so we can see red, blue, and green, and then they're giving us this straight line, which is a linear angle, and a linear angle adds up to 180 degrees. We've dealt with that quite a few times. So this little animation is just showing us that if we take those three angles that we just had within here, they completely fill up this 180 degrees. So it's just kind of a visual way that we can see they add up to 180 degrees, and you can do this with any triangle. So anytime you draw a triangle, as long as they're nice straight lines like this, you could actually cut away the angles and form a linear angle with them, or a straight line. So it's just one of those little pieces that you can definitely test out if you wanted to. So I'm going to go ahead and minimize this guy. And I'm going to refresh the screen because for some reason it wouldn't let me do this on my own screen. I don't know why it stopped letting me cut away the angles. Being argumentative with my program there. Let me turn off the lasso tool. That would probably help. Okay, so now that we know that they add up to 180 degrees, and we've kind of seen the little proof on that, or the reason, is we're just going to go ahead and apply that. If x plus 38 plus 92 equals 180 degrees, we're just going to say x plus 38 plus 92 equals 180 degrees. So we're going to add these two together. So we get 8 plus 2 is 10, 9 plus 3 is 12, plus 1 more is 13. So we get x plus 130 equals 180. And now to solve for x, I just need to move this 130 away, so I'm just going to subtract 130 away. And in this way, too, what we're doing is we're taking the 180 that we know this is our limit. This is what they have to add up to. and I'm subtracting away what I'm already using. I'm already using 130 degrees of that. So what's left over? That's basically the question we're asking here. What's left over of the 180 degrees that I know they have to add up to? So in this case, it would be 50 degrees. That's all that's left over for that x, for that angle there. So I'm going to put check, and ta-da! All right, so next one. All right, so now we're going to look at the exterior angle theorem, and I do think we prove this in a little bit. And I'm going to be a little bit lazy with this one. Instead of drawing it, I'm going to steal a picture of it. There it is. Drop it in there like that, so I don't have to redraw it again. I mean, this one's pretty darn easy to draw, but I'm just being a little lazy with it. All right, so with this one, the exterior angle theorem states that this angle here adds up to the two remote or opposite angles in interior angle. Sorry, I forgot the word interior. And again, this works off of linear angles and the triangle angle sum theorem. So that's where this comes from. And I do believe on one of these questions we prove this. So again, these guys have to add up to 180 degrees, all three of these angles here. And then if I switch over and I look at this linear angle here, they have to add up to 180 degrees because a linear angle or a straight line is 180 degrees. So if I notice this blue section here and this red section here are the same angle. So if I'm adding the same thing to 133 to get 180, or I'm adding the same thing to these two angles to get 180, then they must be equal to each other. These must add up to the same as 133 if I'm adding the same thing to them. So it's kind of one of those little bit of logic, like following that around a little bit. So we can use this triangle or exterior angle theorem to just say 31 plus x has to equal the 133. Because no matter what, I would add the same thing to this, whatever this one is here, which I could pretty easily find if I wanted to, using that 180 degrees idea. I'd have to add the exact same thing to 133 or 31 plus x to get the 180. So we're kind of just ignoring it a little bit there. And so now we're just going to subtract 31 because I want to know what x needs to be. So 31 minus 31 cancels, and we get 102. So 102 degrees for x here. And then if you of course there's more than one way to do this in geometry. Once we get to these triangles and these different theorems or the proofs, there's always more than one way to look at it. So I could very well go through and I could have found what this question mark is here. What is this angle? And then once I know what this one is, I could use the triangle angle sum theorem to fill in what this one was. So this just saves us a step. It's one equation as opposed to two. But either way, you would have arrived at the exact same amount, which is 102. 102 degrees. All right. So now we get a little bit more of an algebraic looking piece here. So I'm going to go ahead and copy that and put it over here. Okay, scoot that over and zoom in on that guy. Okay, so here we have a triangle, and we've been given these three angles. We're not given one right out, so we don't necessarily know what any one angle equals as far as the actual degree, but we do know the algebraic expression. So h is equal to 4x, f is equal to x plus 6, and g is equal to 3x minus 2. So we have these algebraic expressions for each one. What we do know about any triangle is that they have to add up to 180 degrees. So the sum is 180 degrees for these three angles. So if I know that, I can immediately start using the triangle angle sum theorem. So I can say triangle, angle, sum, which means they add up to 180 degrees. So it's very shorthanded. So 4x plus x plus 6, so I have two angles, and then my third angle is 3x minus 2 equals 180 degrees. They have to add up to this 180. And I think I've seen this same one, it might have been on the notes pages when we were doing it, that it had a 90-degree angle, that's kind of another theorem that we can use. If they did give you one of these that was a right angle, right away you could fill it in with 90 degrees if it tells you that it's a right angle. We don't necessarily know that right away yet. This guy kind of looks like a right angle, but don't trust the diagram. Actually work this out. But I know I had one of the examples literally tell us that it was a right angle. So use those words. So if you use those words, you can fill it in with 90 degrees and then start working forward from there as far as filling this piece in. So we're going to add some like terms together. So we have 4x plus 3x, so that's 8x. And then I have 6 and negative 2, so that's plus 4. 6 minus 2 is 4, equals 180. And then I'm going to subtract 4 from both sides because I want to start solving for this x. So 8x equals 176. And now I'm going to divide by 8. And x equals, let's see, we get 2 there because it goes into 16. And I have 1 left over, so it goes into 16 again, so that's going to be 22. So we have 22. Now, is this one of my answers? No. But do I need this to get my answers? Yes. I need to know what x is to fill these in. So for 4x, I'm going to go 4 times 22, and that's going to get me 88. So this guy's 88 degrees. So it looked like 90, but it was 88. And this one over here, we have 22 plus 6, so we get 28, and that was F, so I'm going to go 28 degrees. And then we have 3 times 22 minus 2, so I get 66, because 3 times 22 is 66, minus, sorry, that's not times, that's minus 2, so that would be 64. And if I wanted to check this really quick before clicking check, I could just make sure that these in fact do add back up to 180 degrees. Alex is pretty nice about this. If you click check and it wasn't correct, it's going to let you try it again. It's not going to give you a brand new problem. She's going to say, oop, that wasn't quite right. Try again. Go back and fix that.